All right, today's lesson is going to be on reviewing writing equations of lines. So we're going to be looking at slope, finding slope from a table, from a graph, from ordered pairs. We're also going to be looking at writing equations of lines, looking at our three forms: standard form, slope-intercept form, and our point-slope form. So just a reminder what slope and rate of change are. Linear functions are functions with a constant rate of change. The fact that these rates of changes are constant is what gives us that line. And in a table, a constant change in x corresponds to a constant change in y. You can see on the table to the side, this change in x is a positive 1 for every hour. And then over here in distance, our change in y is negative 50. You see change in y and change in x a lot with delta y over delta x in science classes. Our change in y over change in x is really just our slope formula, which is our y2 minus our y1 over the x2 minus the x1. Excuse me. So here we can see with a slope of a graph, when we're given a slope on a graph, the easiest way to find that slope is to use our rise over our run. Let's count how many this how far it takes to go up and over to a point, or down and over. So something that's important to remember is our rise. If we're going down, that means that value is negative. And if we're going up, the value in our numerator is going to be positive. Our run tells us left and right. If our run is negative, that tells us we're going to the left. And if our run is positive, that means we're going to the right. Because a lot of times we are dealing with fractions or numbers, if you're ever dealing with a number that is not written as a fraction, you can always put it over 1. Now, it's important when you're doing these types of problems, when you're trying to figure out the slope on a graph, pick 2 points. Pick 2 points on the graph and count the rise and run. So if we're looking at something like number 1, I might pick these 2 points. I'm going to start at 0, 0, and then at 2, 1. And if I like to just kind of automatically draw a little right triangle, either above or below. It does not matter. You can also draw your right triangle here. But again, since I'm doing rise over run, I like to do my up and down first. So I'm going to go up to get to that point and then to the right. So now I can see I'm going to count. I'm going to go up 1, so that's a positive 1. And then I'm going to go 2 to the right, so that's a positive 2. So my rise is a positive 1 over my run, which is a positive 2. So that lets me know my slope is a positive 1/2. If we're looking at something like number 2, again, if I pick 2 points, I'm going to pick this point here and this point here. And if I draw my right triangle, here I'm going to draw it below the line. And then I'm going to count. I'm going down 2. So that's going to be a negative 2 since I went down 2. And then we're going 1, 2, 3 to the right. So it's a positive 3. So my rise is a negative 2. My run is a positive 3. So my slope is a positive 2/3. Remember to always simplify your fractions. Looking at number 5 here, a slope from 2 points. Again, this is our slope formula. y2 minus y1 over x2 minus x1. A nice little thing to remember, label your x1, y1, and x2, y2. That's going to make it easier so you don't make mistakes when you're plugging into your slope formula. So for this first point, 1 and 7, I'm going to label this x1, y1. I'm going to label my second point x2, y2. And now this makes it easier to plug into our slope formula. So I'm going to do y2 minus y1, so 10 minus 7 over x2 minus x1 is 5 minus 1. 10 minus 7 is 3. 5 minus 1 is 4. So my slope is just 3/4. Unless they tell you to write it as a decimal, write your slopes as fractions. It makes it easier for you to graph later on. So with our equations of lines, it's important that we know how to get our slope, because a lot of times we need to be able to identify the slope before we can write our equations. We have 3 different forms. We have slope-intercept form. This is the one that most of you should remember and always remember, where the m is the slope and the b is the y-intercept. We also have our standard form. Now with our standard form, it's a little harder to graph. However, we can figure out the x and y intercepts easily from standard form. We make our y0 for our x-intercept and our x0 for our y0 for our x-intercept and our x0 for our y-intercept. A lot of times we're going to ask you from standard form to just convert into slope-intercept form, and from there identify the slope and the y-intercept. It makes it a lot easier. But in class, we will go over some problems where, given standard form, we're going to identify these x and y intercepts. The other one we're going to be looking at is point slope form. This is the one that I want you to get used to using. This is the easier one of the 3. A lot of times in Delta Math, it'll ask you to just leave your answer in point slope form, meaning you just plug it in and there's no work after that. You don't have to put it in slope intercept form. But if they do ask you to rewrite it in slope-intercept form, it's really easy for steps to take once you plug into point slope form. And that's what we'll look at right now. So with our linear equations, we have 2 ways of writing our linear equations. We have using our point slope formula and our slope-intercept formula. So with our point slope formula, our x1, so right here, represents the x coordinate of the point that's given. Or maybe they gave you 2 points. As long as you pick one of those points, and you might have already labeled it x1 if you're trying to figure out the slope. The y1 is the y coordinate of the point. So that is where you put your y1. And lastly, we have our m, our slope. So in order to do our point slope formula, we need exactly what is said. We need a point and a slope. So here it says, our strategy when using our point slope formula is plug in the ordered pair, the x1 and the y1, and the slope, and then just solve for y. 2 steps. So we're looking at this example here. We want a point that goes through -7, 8 with the slope of -2. I'm going to label x1, y1. That's going to help me plug into my x1 and my y1 of my point slope formula. My slope, my m, is -2. So I'm just going to be plugging into that point slope formula up on top. So we have y minus, and then my y1 is 8. My slope is a -2. That's the next part. After the equal sign is the m. And then parentheses, x minus, and then my x1, which is a -7. Right here, these 2 negatives turn into a positive. And now step 2, solve for y. So we have y minus 8 equals, and here I'm just going to distribute. -2 times x is a -2x, and then a -2 times 7 is a -14. To solve for y, all I do is add 8 to this other side, and we get y equals -2x minus 6, and we're done. The great thing about point slope form is that I don't have to then remember to go and plug rewrite my equation. And you're going to see that over here on this other one. So we're going to do the same problem, but we're going to use a slope-intercept formula. And this is the one that you're probably used to doing. So my m is just my slope, and my b is my y-intercept. So the strategy here, we plug in the ordered pair, the x and the y that they give us, the point, and the slope. But then we have to solve for b, because we don't know the y-intercept. They gave us the slope, but we don't know the y-intercept. So we have to figure it out using the point and the slope that we know. So we're going to be using the y equals mx plus b. I have an x and a y here, and I have a slope of -2. So I'm just going to plug in my x, my y, and my m. So we have 8 equals -2 times my x of -7 plus b. So I need to solve for b here. We get 8 equals 14 plus b. Subtract 14 to the other side. I get -6 equals b. But I'm not done yet. Now that I've solved for b, now we're going to plug the m and the b into y equals mx plus b. So we have y equals, my slope is -2, so -2x, and my b is a -6. Notice how it's exactly the same. It's just a little bit more work, because you have to remember after you solve for b to go back and rewrite it in slope-intercept form. All right. Next, we have horizontal and vertical lines. Horizontal and vertical lines. Now, these are special type of equations. These are special types of slopes. With a horizontal line, we have a 0 slope. If we were to do our rise over our run, right? If I pick a point on here, say I pick this point and this point here, my rise to go from here to here is 0. I don't go up anywhere. I would run over 1, 2, 3, 4, so my rise over my run is 0 over 4. And 0 divided by 4 is just 0. It is not a no slope, it is a 0 slope. My m equals 0. Therefore, we have a special type of equation. If I actually plot some points, so let's say I use this 0, 4, and then this one was 4, 4. Let's say I pick -2, 4. You should see a pattern here. Notice that all points have y's that are 4. 4, 4, 4. That actually tells you the equation of this line. It does not matter what your x values are. Your y's are all equal to 4. So anytime you see points that all have the same y values, you're going to have a horizontal line with the equation y equals 4. If we have, in this case, a vertical line, this is an undefined slope. And the reason is, if I do a rise over run, say I pick those 2 points, my rise is 2. My run is 0. I'm not going anywhere else. I'm just going straight up. Well, if I try to plug that into a calculator or know the rules of dividing by 0, it is not possible. That is undefined. It is not 0. You can also sometimes see it as does not exist. You might also see it as no slope. But here, it's a special type of line because it is not a function. And because it's not a function, we can't write y equals. So if we look and we pick 2 points, or let's say we pick a few points, These are the points -2, 4, -2, 2, -2, 0, -2, -2. Here, the pattern is, whoops, that my x's are all the same. They're all -2's. So here, my equation for that vertical line is x equals -2, because my y values don't matter. My x's are always going to be -2 for any y value. So these are special types of equations for horizontal and vertical lines. So like for this one here, they're giving us a slope of 0. So if I have a slope of 0, I know I'm going to have y equals. Well, if I look at my point, it needs to go through the point y equals 1, so that I can go through the point 2, 1. Here, if it's undefined, I know it's going to be x equals. Well, x equals, according to this point, -3. So when you're given a slope of 0 or undefined, the equations are very simple if you know another point. If you don't know a point that it needs to go through, it's really easy. Slope of 0 is going to be y equals, and then whatever the y equals of that point given, in this case, -3. Undefined slope is going to have a slope equation of x equals, and needs to go to the point 1, 2, so my x equals 1. So there's not a lot of work to get the equations of horizontal and vertical lines. It's about understanding that a slope of 0 goes with y equals, and an undefined slope goes with x equals. Now, what happens when I give you 2 points? So given 2 points, let's say I give you -21, 8, and 78, 74. I want to find the equation given 2 points. So before, we did a point and a slope, but now we just have 2 points. I'm missing the slope. So step 1 is to find the slope. And like I said before, always label your points. I have -21, 8, and 78, 74. And I'm going to label these. x1, y1, x2, y2. I'm going to plug that into my slope formula from before, which is y2 minus y1 over x2 minus x1. These two negatives are going to turn into a positive. So 74 minus 8 is 66. 78 plus 21 is 99. Always reduce your fractions, so we get here 2/3. Your calculator will simplify fractions for you. If you don't know how to do that, we'll get to that in class. Now that I have my slope, we need to write the equation. And this is where you choose which one you want to use, if you want to use point slope form or slope intercept form. We're going to do point slope form here, and then we'll do another problem where we're practicing slope intercept form. So we're looking here at this x1, y1 that we already have labeled and our slope. We're going to use that in our point slope form. So y minus my y1 of 8, or I'll write down the formula. So y minus y1 equals the slope times x minus x1, and I'm just going to plug in my x1, y1, and my slope. So my y1, according to the point that I've already labeled, is 8. My slope is 2/3, and then x minus my x1 that I already labeled is a -21. And now I'm just going to solve for y. These two negatives turn into a positive. So we have y minus 8 equals, and here I'm going to distribute. 2/3 times x is 2/3 x. 2/3 times 21 is a positive 14. And then to solve for y, we add 8 to both sides. We're left with y equals 2/3 x plus 22. Now I know step 3 here says to check the point, but you only need to check a point if they're asking you if there's another point on that line. So we're going to go ahead and skip that step here. We don't need to do step 3. Now, like I said before, sometimes you're going to get some equations that are in standard form. And if we know about x-intercepts and y-intercepts and where they fall on a graph, it makes it a lot easier to identify our x and y intercepts from standard form. So I know that for an x-intercept, it needs to cross the x-axis, and this would be the x value, comma, 0. My y is 0 on my x-intercepts. For my y-intercept, make that clear. So for my y-intercept, my x is 0, and I'm looking for the y value. That makes it easier to identify that x-intercept when we're solving for something. So for x-intercept, this is where the graph crosses the x-axis, and we know that that is an ordered pair x0, so we always make your y equals 0 when we're solving. For the y-intercept, this is where the graph crosses the y-axis. This is the ordered pair 0, y, and my x's are equal to 0. In class, I'm going to teach you what's called the cover-up method to solve these. It makes it really, really easy to solve our x and y intercepts. So I'm going to show you that in class. So with this one here, we're going to graph these 2 points. I mean, not graph them. We're going to figure out the equation of those 2 points. So we're going to use slope-intercept form here. So we use point slope on this one here with those 2 points. Here we're going to use slope-intercept form. So first thing we have to do is we have to identify our slope. We're given these 2 points, so I'm going to label this x1, y1, x2, y2. So for my slope, I'm going to use my formula and plug my values in. So this is -3 minus 3 over 1 minus a -2. These 2 negatives turn into a positive, so we're left with -6 over 3. So my slope is a -2. Step 2, we're going to plug in a point, and that can be either our x1, y1 or our x2, y2. It does not matter. And the slope into our y equals mx plus b. Then we solve for our b value, or our y-intercept. So here we have our y. I'm going to use this first point here. It does not matter which point you use. You can use any point. You can also use that 1 and -3 if you want to. So I'm going to use -2, 3 for my y, my x and my y. So if I'm plugging into y equals mx plus b, that becomes 3 equals my slope, which is -2, times my x, which is -2, plus b. Solve for b here, we get 3 equals 4 plus b. Subtract 4 to the other side. we get -1 equals b. So our last step, step 3, we plug our slope and our b, our y-intercept, into our y equals mx plus b form. So that gives me y equals our slope of -2, x minus 1. So again, when you're given 2 points, first find the slope, then write the equation, either using point-slope form. In this case, this example, we use point-slope form. On this example, we use slope-intercept form. Either one will give you the same answer. Just be careful when you are doing a delta math question. Make sure if it says to use point-slope form, you can stop right here. You're done. It doesn't care about your slope-intercept form. If it doesn't specify to put it in slope-intercept form, you can leave it as point-slope form, which makes it a lot easier when you're putting in your answer. If it says it has to be in slope-intercept form, then of course, use either way. Solve for y over here. On this one, solve for your y-intercept, and then rewrite it. Last one we're going to look at, let's look at this one here. We're looking for an equation that goes through 5, 1 and 5, -7. And we're looking for the equation. So I'm going to label first x1, y1, x2, y2. So our first step, like always, is identify the slope because we don't have one yet. So our slope is y2 minus y1 over x2 minus x1. When we solve, we get -8 over 0. Uh-oh. We can't divide by 0. Therefore, this is an undefined slope. And we know from our notes, when we have an undefined slope, x equals is going to be our equation. So I need to go back to my points and look at my x values. Both of my x's are 5. That lets me know that my equation is going to be x equals 5. If we look at the next problem, without even doing any work, notice that both of my points have a y of -1. Right away, I know my equation is going to be y equals -1. You don't even need to do any work for these types of problems. If you can look at your points and notice that pattern of, oh, all the points have the same 5 value or x value, then it's going to be x equals. All my points have the same values. That's going to be y equals. Then there isn't a lot of work necessary for those. In class, we're going to be looking at more examples together. We're going to go over some delta math problems together. And if you have any questions, please make sure you come prepared to ask them in class.